Did you guys win?
No.
No? How bad did you guys lose?
I don't know about varsity, but JV lost by 2.
Oh.
Well, you guys won by 10, right?
Huh?
About by 10 strokes.
What, varsity?
Yeah.
Yeah, something like that. They
Like
play
that.
better there than years in the past.
Oh yeah? Yeah, that's what I thought.
By like 10 strokes.
All right, we should be able to get through. We're not going to get through all of this by design. We're going to finish it up tomorrow. But we should get through most of it through the back. 87. What'd you get for 87? What's your equation on Justin? Go with you.
X minus 2 squared plus y minus 5 squared.
X minus 2 squared plus y minus 5 squared equals 26. All right, that's correct. Make sure yours should equal 26 for that. So just double check that one. I saw looking at a few of them. That was one that was missed on some papers. All right. Let me get attendance here real quick. I forgot to. Olivia, Ben.
We're losing
You can drive.
5 to 6. So, Coach hates our class. It's just
You can
hard.
take back roads. It's not that hard.
So is Cole from
He likes those on.
I don't know. I haven't gotten
Any other questions on anything else in the homework? Carter, you good? Yeah. Tessa? All righty. Okay, we're going to move into those guided notes here, talking about relations, what makes a relation a function, and main thing we're talking about today is the domain and then also the range of a function. So on that top there, okay, any set of ordered pairs? It's called a relation. Okay, so that'd be that first thing. The set of all first components is called the domain of the relation. In math, you're used to that being just your x coordinate. And then the set of all second components is called the range of the relation. And now what makes a relation a function? Did I not give you one?
No.
All right. Anybody else? And that next part, what makes a relation a function? In that case there is where each element of the domain, each x value, corresponds to one and only one element of the range. Okay, so 1x, where an x goes to 1y, cannot go to 2. Now, relations do not, and functions do not always have to be just x's and y's or numbers. You can have anything as a set. So in this case here, is that first example a function? Okay. It is, because each one goes to a single number. It doesn't matter that both Ellen and Dwayne go to 11, as long as they only go to 1. That is a function. The next case there to the right is something that's not a function, because Malcolm is paired with 2 numbers, Maria is paired with 3 numbers. So once one person is paired with more than one number, not a function. Good for that. Graphically, it's pretty easy to tell whether something's a function. You've learned this for a while. You got the vertical line test. Okay. If a vertical line hits it twice, it's not a function. If the vertical line hits it one time at all points, then it is. So if you take a look at that next one there to the right, this one is a function. And if you draw a vertical line, no matter where you put that vertical line, it will hit this graph only once. But if you put it over there, perfect. It hits it more than once, so this would not be a function. Okay, not a function. So vertical line test is a good way to tell for the graph. All right, we're going to be concerned when we get a equation determine what the domain is. Two key things we need to remember. First one, division by zero is undefined. Cannot divide by zero. You cannot use that number in the domain. And number two, the square root or any even root of a negative number is not a real number. So everything we're graphing is on the real number system. So if we get something that gives us a negative under the square root, we cannot use that in part of our domain. Okay. Another way to think about it, no zeros in the denominator. Okay, just restating the same thing. No zeros in the denominator. And only positives under the square root. And I need to amend that just slightly because technically only positives and zero. You can take the square root of zero because that is just zero. So that can be in the domain. You can have zero under a radical. Cannot have a negative. All right, take a look at that first problem down there. It says identify the domain, and we want to write the domain in interval notation. Domain are all the values you can plug into the equation for which we will get an answer back. Okay, so f of x equals square root of 2x plus 8. Well, what's the thing? Cannot be what type of number underneath the square root? Cannot be a negative. So 2x plus 8 has to be greater than or equal to 0. Okay, so algebraically, you can set this up. Subtract 8. Divide by 2. X is greater than or equal to negative 4. All right, I want you to put that interval notation. Also, go ahead and pull your calculators out. Graph that function on your calculators. I want you to see how the graph corresponds to the domain. So in interval notation, the domain is going to be bracket negative 4 to infinity. Now, how's that going to look like on our graph? So I got square root of 2x plus 8, and I'm going to hit graph. You need to make the connection that there's going to be nothing to the left of negative 4. Okay, those are the only numbers we can plug in. So those are the only values that are going to show up on the graph. If I go to the table and I go to negative 4, I get an answer back of 0. So it exists at that point. And then at negative 5, it's an error. Negative 6 is an error. Everything else is going to be an error. So it starts there and moves to the right. Okay. All right, the second one there. G of x equals 6 divided by 2x plus 6. No radical. But what can't happen? We can't have 0 in the denominator. So what will make this 0? So just say, all right, well, what's going to make it 0? 2x plus 6 equals 0. 2x equals negative 6. X equals negative 3 will make it 0, which means x cannot equal negative 3. All right, how do I write this in interval notation. Everything but -3. Okay. Start at negative infinity. Go all the way to -3, but we don't include -3. Union -3 to infinity. Okay, so if you just exclude one point, everything but one point, negative infinity to that point, union that point to infinity. All right, so we got two distinct sets. Go ahead and graph that on your calculator. Now, if your calculator does not make it into a fraction, you got to make sure you put the denominator in parentheses. Okay, so like if you're typing it in and you do the fraction and it just makes it, you'll be fine. Oh, you thought, that's interesting. Now you got two pieces of the domain. When you graph this 6, y equals 6 divided by 2x plus 6. Okay, you have to get two pieces of the graph. Okay, there's the first piece, negative infinity to -3. There's our second piece. If you go to your table at -3, it says error. Everywhere else, you're going to get an answer. All right, so you got to say, if I got two parts to the domain, I got to have two pieces of the graph. All right, flip it over in the back. And copy that down. All right, there we go. Square root 2x plus 7. Can I have a negative underneath there? So 2x plus 7 has to be greater than or equal to 0. At the same time, x minus 5, we want to find out where that equals 0 because that can't happen either. So I'm going to, so for the first one, subtract 7. 2x is greater than or equal to -7. Divide by 2. Divide by 2. X is greater than or equal to -7/2. Over here, add 5. If x equals 5, it makes it 0, which means x cannot equal 5. All right, think what the interval notation will look like. Okay, think what an interval notation will look like. Got to be greater than or equal to -7/2, which is -3.5, and it cannot equal 5. All right. Maddie, what do you think?
Bracket -7/2, so 5 not included, and then union when 5 goes in.
Okay, I agree. -7/2 to 5, union 5 to infinity. So how many pieces does this graph have to have? It's got to have two pieces. So if I graph this one, square root, let's see here. Square root of 2x plus 7 divided by, now I got to put this in parentheses, x minus 5. And then I hit graph. There's your first piece. If it's just missing that point, it's going to create what's called a vertical asymptote, and then we got the second piece. Now, it's not obvious, but if you go to the table, you'll see that anything past, well, -3.5 is going to give you an error. But everything to the right will continue. All right, copy down that one. All right, think through this one. G of x equals square root of x plus 5 over x squared minus 6x plus 8. Remember, the domain is only it's going to list all the x values for which that graph exists. It will not exist for any other x values. We got a radical. So x plus 5 has to be greater than or equal to 0, which means x has to be greater than or equal to -5. We got x squared minus 6x plus 8. We want to know where that equals 0. That will factor into x minus 4 times x minus 2. This case here, that means x equals 4, x equals 2. So x cannot equal 4. X cannot equal 2. Okay, for that. So we got to combine all those factors together and then come up with the domain. All right, it's going to start at -5. Got to be bigger than equal to that. All right, looking at that, where's it going to go to? What's going to be the kind of first break point?
2.
2. It's going to go to 2. -5 to 2. And then what's going to be next? Okay, it's not going to include 2. After that, 2 to where? 2 to 4. Don't forget about that 4. Union 2 to 4. And then union 4 to infinity. So this one will have 3 pieces to the graph. Okay, so if you graph that one, and let's just do that one real quick. Y equals square root of x plus 5 divided by x squared minus 6x plus 8. And then, hey, sure. Sure. All right, so you got one piece, then you got this piece down below the x-axis, and you got the second piece. So you're going to have, or third piece. So you're going to have three pieces to this. All right, we're just going to take a look at these last two here. All right, you got a finite graph. Basically, you're given the graph. You just need to be able to identify the domain and identify the range for both of those. So look at that first one there on the left. All right, looking at that domain. Emma, what do you think?
I would say, parentheses -2.
Okay.
To 3 with the bracket.
3 with a bracket. So it's going to include everything from -2 to 3. Agreed. Okay, for that one. All right, Bryson, what do you think for range?
Parenthesis 1
Okay.
to 4 with the bracket.
Good. 1 to 4. It's going to include the 4. All right, take a look at that second one. Now, the second one has 2 pieces to it. Okay, first one just had one continuous piece. So we just had one interval for the domain, one interval for the range. All right, as we look at that second one, the first piece is going to go from -3 to +1 for the x's. So it's -3 to 1. Union. All right, what are we going to label? How are we going to label that second part? Alex, what do you think?
A bracket 3, infinity.
All right, it's going to go from 3 to infinity. All right, agree with that. Range. All right, range is going to go from -1 to 1 for that first piece, including both points there. Union what? What's happening with that last little part there? Really, what y value does it hit each time?
4.
It hits 4. It's just a single point 4. And I can put that in braces to indicate that's just a single, just the value 4. Okay. You wouldn't use brackets. Some people use brackets because that's indicating it's an interval. It is not an interval. It is just a point. So we would do that. All right. That is the first part of 2-4. So 37 to 47 odd, and then 63 to 70 all. Oh, we even got done early. Or there.